Hello there, algebras, and welcome to your Chapter 8 Lesson 4 notes. We are going to look into quadratic word problems. And we're going to spend a little bit of time on these because this has a tendency to be where the quadratic equations that we need to solve are going to come from. So they're going to come from some real life situations. They do start with like basic number situations, but then we will also get into consecutive integer situations as well as basic area problems, which is really where the majority of quadratic word problems I've seen on the Regents exam come from. Okay, so those are the three types we're going to get into. As we know, when it comes to word problems, let statements are the key, making sure we identify what is our variable and what is it going to be? What is it representing in our scenario? Okay, that's what we want to be looking at here. So, a classic basic numeral quadratic equation is the larger of two positive numbers is 5 more than the smaller. The product of the numbers is 24. Find the numbers. The fact that product instead of sum, product means to multiply. So the fact that we are multiplying two unknowns is going to square. And that's where that x squared piece is going to come from and how I know it's going to be a quadratic. Okay? So let's kind of go through, like I said, we got a larger, we got a smaller, we got a product, we got positive. Oh, positive. Okay. Larger of two positive numbers is 5 more than the smaller. Positive will be helpful. I'll show you why at the end. How many numbers is the question asking us to find? 2 of them. We need to find 2 numbers at the end. Okay. Now we need to write let statements defining our variables. Well, x can equal your smaller number. Oh, excuse me, smaller positive number. And if that's the case, how many more is the larger? 5 more. So x plus 5 is going to equal the larger, that's my R, sorry, positive number. And now I know that I'm supposed to multiply them. So what I'll do is I'll take x times x plus 5. I multiply these two numbers together and I get 24. The result is 24. So notice this is just a quadratic equation. I distribute, I get x squared plus 5x equals 24. Well, now that I know I have an x squared, I need to get standard form. So let's subtract that 24 over. I get x squared plus 5x minus 24 equals 0. And now I think, well, gee, what are the factors of 24 that are going to subtract to give me 5? And that would be, let's see, not 24 and 1, not 2 and 12, not 4 and 6. Oh, I skipped one. 3 and 8. X plus 8 and x minus 3. Let's consider if I did that factoring correctly. Which is the bigger factor, 8 or 3? 8 has to have the same sign as the middle, which, because this was a positive 5 in the middle, the 8 has to be positive here. There we are. Okay, so now I T-chart, set each factor equal to 0. X plus 8 equals 0, and x minus 3 equals 0. And so I get 2 answers for x. I get x equals negative 8, and x equals positive 3. Now, what I need us to consider is what the question was asking for. So I'm going to read again. This is when I get to the end in a word problem, I'm going to reread my word problem. The larger of two positive numbers is 5 more than the smaller. The product of the numbers is 24. Find the numbers. 2 positive numbers. One of my answers for x is not positive. So because one of my answers for x is not positive, it's not a possibility. So we cross it out and we write reject. And the reason it's not a possibility is because the word problem specifically says I need a positive answer. So that means that x has to be 3 and 3 plus 5 is 8. And do these two positive numbers product, meaning multiply, to give me 24? Yes. This is called an extraneous root. When you get an answer for x that doesn't make sense in the situation, we reject it and we call that an extraneous root. Okay? So, my final statement here, right? Are there any solutions that do not fulfill this question? One of the two solutions does not fulfill this question. One or yes, whichever you want to answer there. And that's an extraneous root, not part of the answer, because it doesn't fulfill the question at hand. Final statement, 3 and 8 are two positive numbers. Sorry, I was going to write integers, but it's numbers whose product is 24. This is enough, by the way, for a final statement. I just wrote one out because, well, finishing up our problem, making sure we answered all of the parts. I have an idea. Since we have a second one right here, I want you to pause and try this next one. Again, make sure you have everything down that I've just done for the first one, and then pause it to do number 2. Now, before you pause it for number 2, let me just read number 2. The square of a certain negative number decreased by 35 is equal to twice the number. Find the number. Always start with let statements. Start with your let statement. Let's see how we do on our own. Give it a shot. Pause it here. I'll see you in a sec with an answer. See you in a sec. Okay, so let me walk you through how I did this one. The square of a certain negative number. Oh, well, that's my variable. So x equals a certain negative number. So negative was the key here, right? Decreased by 35 is equal to twice the number. Okay, the square, so x squared, minus 35, so decreased by 35, is equal to, that's pretty basic, twice that number. So twice x, 2 times x, right? So now I've got this x squared over here. I need to subtract 2x over to the other side. I put it in descending exponential order. I think, oh, what are the factors of 35 that are going to subtract to give me negative 2? So that's 7 and 5. 7 is the bigger factor, so it has to match the sign in the middle. So that's the negative 7. Positive 5, because they have to have opposite signs. T-chart, I get x equals 7 and x equals negative 5. But what specifically was I looking for this time? A negative number. So this time x equals 7 was my extraneous root, and I rejected. So my answer here, since my answer was find the number, is negative 5. These are specific, just basic numeral problems that we were looking at here. You're going to have one of each of these types on your homework tonight, okay? One of each of these types. And speaking of types, our next type is consecutive integers. So we discussed consecutive integers back in chapter 1 when we first started all of our algebra work. Consecutive integers are one right after another. So consecutive integers are represented by x and x plus 1 and x plus 2. So if that's 3 consecutive integers, they're right in a row, adding 1 each time. Consecutive even integers are every other. So those are x plus 2, x plus 4, because they're every other. And the same with odds, because they're every other. Okay, so it's still x and x plus 2 and x plus 4 as our consecutive odd integers. Okay, because there is still every other. As long as your x that you start out with, is even, adding 2 and then adding 4, that's going to keep my numbers even. If it's odd, adding 2 is going to keep it odd, and adding 4 is going to keep it odd. Okay, so as long as that specific first x matches the even or odd specification, the x plus 2 and the x plus 4 will just continue that trend. Okay, but even and odd are the same representation. Okay, so you can kind of think of them that way, right? If it's even or odd, it's every other. If it's just consecutive integer, it's right in a row. The product of two positive consecutive integers is 56. Find the integers. Got it. So wait, I need two answers at the end. Okay, so x equals my first positive consecutive integer. And then the next one is just consecutive, so x plus 1. So the next one is my second positive consecutive integer. Got it. Okay. Well, product means to multiply, and that's typically what we're going to have here. So x times x plus 1 equals 56. Okay, distribute. Scooch up. Distribute. I get x squared plus x equals 56. Okay, subtract that 56 over. X squared plus x minus 56 equals 0. What are the numbers that will multiply together to give me 56, but subtract to give me 1? That would be 7 and 8. 8 is bigger, so it gets the same sign as the middle. That leaves 7 to be the minus, and I will now t-chart. So I get x plus 8 equals 0, and x minus 7 equals 0. And so what are my answers for x? Scooch up just a tad more. That would be x equals negative 8 and x equals 7. And are there any extraneous roots? Let's reread. The product of two positive, we have to reject negative 8. That is and that is an extraneous root. It's not positive. X equals 7 is positive, right? And plus 1 is 8, and 7 times 8 is 56. So their product does work, but notice I had to reject that negative answer because I can't use it. It's not a positive consecutive integer. Okay? Why don't you try? After I read it, pause it, and try number 2 on your own. Make sure you have all that I just did written down so you know exactly how to tackle this one. Okay? And then, of course, I'll come back and I'll show you what I get. The product of two positive consecutive even integers is 360. Find the integers. So positive consecutive even, careful on your let statement, and then find the integers. There's two answers at the end, right? Or more than one answer at the end, right? Two positive, two answers at the end. Okay, you got this. Give it a shot. I'll see you soon. Pause it. Try it. Seriously, try it. Start with the let statement. Go. Okay. So my answers are 18 and 20. And that makes sense. 18 and 20 are positive, consecutive, even integers. They multiply together to give me 360. How I found that was x is equal to my first consecutive positive even integer, and x plus 2 is my next one, and I multiplied those together in an equation. So x times x plus 2, that meant distributing, so I get x squared plus 2x is equal to that 360. Then, of course, when I go to factor the trinomial, I subtract that 360 over. And when I go to factor the trinomial, because of the problem, I honestly really was trying to think of what are two numbers that are really close together, only two apart, that multiply together to give me 360. And you know what I thought of was 360, if I drop the 0, is 36. And I know that 18 times 2 is 36. So if you put the 0 back in, boom, now you got 18 and 20. Okay, so that's what I was thinking of. That was how I got to my factors a little bit quicker. And then, of course, I t-chart. I noticed that I'm supposed to have positive answers. So I reject my x equals negative 20. That's not going to work. It's not a positive even integer. And then, of course, I use 18, and 18 plus 2 is 20. 18 and 20. Then I checked it in my head. You see how I was talking through the check, right, to make sure that those multiply together to give me 360? Well, that's one of the things you want to make sure you're doing as well. Do your answers make sense? If you get decimals and you were supposed to get integers, your answers don't make sense. That means something went wrong and you got to try again. Last, but certainly not least, because this really is where the majority of these word problems come into play, is of course the area problems. Okay, so now on to area problems, which, because area is going to be a length times a width or a base times a height, whatever that area formula is, it's always one dimension times another, meaning that if both dimensions are your variable, they're going to result in an x squared. So these are also going to result in quadratic equations to be solved, right? So let's take a peek at these two area problems. I'm actually going to do both because they are different figures. So we do need to know different area formulas. The region should have your area formulas available, but we should know those at this point. So I'll just show you what they are in these two examples. So we'll start with a rectangle. Make sure you know what a rectangle looks like. I know that sounds very elementary to say, but draw the shape and make sure you have the right shape that you're looking at, right? So a rectangle has an area of 27 square units. The width is 6 less than the length. What are the length and width of the rectangle? Okay, so this time my let statements are actually going to be that diagram I'm telling you to draw. So draw a rectangle. Okay, and within that rectangle, write the area formula for that shape. Okay, so we've got a rectangle. The area formula for a rectangle is length times width. The width is 6 units less than the length. So width is 6 units less than the length, right? So I did that backwards for my letter. I'm going to use W, or I'm going to use L instead of W. So let's do L, and then L minus 6 is my width. Length, width. They multiply together to give me my area, which is 27 units squared. So if I know my area is length times width, then I plug into the formula 27 equals length times width. Try to keep that going again instead of writing my minus sign. There we go. And of course, I have to distribute my L. So I get L squared minus 6L. And of course, I've got this 27 over here that needs to be subtracted over to the other side. And I'm going to do things in order. So I've got L squared minus 6L minus 27 at the end. So now I've got my trinomial that's factorable. What are the factors of 27 that are going to subtract to give me 6? So that would be 9 and 3. Yeah, that'll work. What sign on the 9? What sign on the 3? Well, 9 is the bigger factor, so it's got to be the same as the middle, so that's where your negative is. Your 3 must be the opposite because your end term is negative, so positive 3 inside your binomial. And then you t-chart. Since we're equal to 0, set each equal to 0. And we get L plus 3 equals 0 and L minus 9 equals 0. So my L equals 9 and negative 3. Now, question here. Are there extraneous roots? Did it explicitly say in the word problem to reject the negative or to reject the positive? No, but let's think logically. Can you have a negative length of a side of a rectangle? So in these, while it won't say you need to keep the positive answer and reject the negative answer, it's implied that we need to reject any negative sides. So actually, my length is 9, and 9 minus 6 is 3, so my width is 3. Length times width, 3 times 9 is 27. There you go. Because I needed to know what are the length, what are the width, I made that very clear in my final answer. Okay? Made that very clear with my final statement. Now, of course, let's do the next one together too. Normally, this is where I would pause it and have you do it, but it is a different shape. And so I just want to be clear about you need to make sure whatever shape you have the correct area formula for, and you have the correct diagram for. So in this case, number 4, the base of a parallelogram measures 7 centimeters more than its altitude. If the area of the parallelogram is 30 square centimeters, find the measure of its base and the measure of its altitude. So again, we're finding the dimensions, but a parallelogram is kind of a rectangle that's like slanted, right? And in a parallelogram, here is your base, and the two bases, the top base and bottom base, are of course equal, congruent, but the altitude is the line, the vertical line drawn straight down, making a right angle from one base to the next. So it's this distance that is your altitude. So when we say that the base of a parallelogram is 7 more than its altitude, you can say that A is its altitude and A plus 7 is its base. Now, for the area of a parallelogram, it's A equals altitude times base. I think we usually call it base times height. The altitude and the height are the same thing. So what we'll do is we'll say, okay, we know that the area is 30. So if we're plugging into base times height, we've got 30 for the area. The base is our A, the base is our A plus 7. Our height is our A, and now we have that to distribute. So since we're basing things on the altitude or the height, let's distribute that A squared plus 7A, and of course subtract that 30 over. So we still get the same idea going here. Okay, still have to get one side equal to 0 because it is, I just want a minus, not an equal, because it is a quadratic, and having the squared variable is what indicates to me that I've got a quadratic. And then I think, well, what are the factors of 30 that are going to subtract to give me 7? So 10 and 3. And let's see, 10 is bigger, so it has the same sign as the center. And of course, 3 has to have the opposite sign because your n number is negative. And now we t-chart. So A plus 10 equals 0, so A equals negative 10. And A minus 3 equals 0, so A equals 3. And yes, we get to reject the negative 10 because that can't be the length of a side in a shape. So A, our altitude, is 3 centimeters, and 3 plus 7 is 10 for the base. The measure of the base is 10 centimeters. The measure of the altitude is 3 centimeters. And since I know units, why don't I label units? There you go. 3 times 10, 30 centimeters squared. When you are doing an area problem, you will reject the negative because you cannot have a negative length of a side in a shape. So implicitly, we know that these values have to be positive because they exist as sides of a shape. Okay? Alrighty. Oops, I want to go the opposite and I want to zoom out. This has been your Chapter 8 Lesson 4 notes on quadratic word problems. We had 3 different kinds of word problems. You're going to look at one example of all three on homework number 1. Then we'll try again homework number 2, but please ask me questions if you have them. These are the questions that tend to get used on the Regents exam the most to test your quadratic solving ability. Okay, so you do have to make sure you are writing let statements, either writing them as we did in the first 2 examples or drawing the shapes and labeling the sides. Okay, then of course, solving your quadratic equation, and that's what we did in lessons 1 through 3. Okay, but then remembering to actually cross out and write reject to answers that don't work in our scenarios. Okay, so you have to make sure your answers make sense in the word problem scenario that you have. All right, guys, please ask me questions if you have them. Otherwise, good luck, and I will be seeing you soon for, I believe, homework number 3. I think there's 3 of these, and I think I'll do a video for homework number 3.